Alright, hello again. This is Dharma2, week 5. Quick recap of last week, having some ordering issues with some parts, picking out a storage element, and testing current devices. So again, I filled out the information for the Korean and Canadian parts, the Korean company being Tegway, and the Canadian part being TechTag. And the Korean Tegway parts, it's the flexible tag stuff, which would be really exciting to work with. And then the TechTag stuff is very crucial to this project. So between the two of them, of course, I believe that the Canadian parts are much more likely to get approved. But we'll just have to kind of see what procurement services has to say about it and make sure I do all the paperwork correctly. So waiting on Woody and whoever's up the chain to tell me what my next step is. But luckily I took the initiative and ordered some tags just off of Amazon so I could get some testing done and kind of understand how everything works. Additionally, the EVK 3300 board came in super quickly, so I am good to go on that. I have that in my possession. So with these two parts, I did a bunch of tests, and for the 3300, there is a lot of stuff going on. So it's been helpful going through the pages and pages of data sheets. I mean, there's 4 separate documents of instruction over this board, so which is helpful, but also it's very complicated, so I was able to do a little bit of that. So to start, of course I'm looking into a storage device, and when I opened up the box, the first thing it said was, after putting the jumpers in, of course, get a storage device and hook that up, for protection and everything. So I was like, okay. And then how do I pick out a storage device? So they had a guide on their website. As you can see here, this is a snippet from it. You can either start from your power source or how much power you're going to need to power your application. And there's some formulas you can use. The trick is, in order to kind of make some progress here, I need to have an boost. And it says it's on the datasheet, but I looked through all 4 documents and I did not find that value. So I'm going to keep looking. But fortunately, let's see if it's on the next slide. It's not. There is you don't have to have a battery storage device. If you don't want to, you can just have the harvester directly power any circuit if you'd like. However, if you choose to do that, you have to hook up a 100 microfarad minimum capacitor in order to just protect the device. Otherwise, it'll be permanently damaged. So at least now I have a minimum, which is 100 microfarads, just as a minimum cap. And then from there, I was able to look at the configuration chart. And so it says these are a bunch of pins on the board itself. And depending on how you hook these up, it represents different voltages. The VOVCH, this one, it's the max voltage that the storage element can accept before it stops charging. And the VCHRDY is the minimum voltage required on the storage element before there's like a logic pin that will go high. And then the VOVDIS is the minimum voltage before resetting that logic pin. So essentially what I need to figure out is, what do I want how much power am I actually going to be able to deliver to this device based on my tech? And then once I figure that out, I can pick out which kind of battery I want to use. So I'm hoping to get a single cell supercapacitor. The dual cell, there's some special setup that I have to do for that. I have a lithium-ion battery, but I think it exceeds all of this, so I'd have to order something anyway. So that's kind of where I'm at. I don't want to go into custom mode because anytime you go into custom mode, you have to really know what you're doing. And at this point, I'm not confident enough to kind of make some stuff up. I want to play by the book until I'm ready to move on. So here's a video of me doing some tests. I'll skip it for now, but it'll be available to you in case you want to watch it. I set up my tag and I attached it to a simple, just a green LED, and then I ran a multimeter. And what I found was it's super, super sensitive. Even like just I don't even have to touch it, just passing my hand over it can increase the voltage. Not a lot, of course, but it's very rapid. Ambient, just like sitting on my desk, is, you know, fluctuates anywhere from 0.5 millivolts to 2 millivolts, just kind of chilling. Not much is happening. If I just set it on top of my wrist, it doesn't have good contact. It doesn't, you know, there's not really a lot of temperature change going on. It's 16 millivolts. If I rest it on top of my wrist and then put an ice bag on the other side of that, then it jumps up to 580 millivolts. So I can tell that a lot of it is, well, first of all, like if I put my hand on it and I rest my hand on it, it gets up to about 100 millivolts, maybe even more. So there's like tiers here, of course. So pressure is a lot to do with it because you get an increased coverage. And then the ice bag helps a ton. We get 580. The highest I was able to get was with using an ice bag and a lighter on opposite sides. So that got all the way up to, I mean, it was almost a whole volt, which is very exciting in terms of if I can have a couple of these maybe in parallel, then I can, you know, be well on my way. I won't be generating voltages like 880 millivolts just with one person, but at least I know that we're getting enough voltage to do something with, especially with the board being able to boost it and everything. Additionally, because the board has a cold start power minimum of 275 milliwatts, oops, that should say millivolts. It needs 275 millivolts for a cold start, and the tag tends to spike up, like, oh, suddenly there's a temperature change, let me boost up my voltage, and then as the device kind of settles temperature-wise, it'll go back down, you know, let's say 50 millivolts or so, and then kind of settle. But that's okay, because once the device is on, then it only needs 100 millivolts to run. So that's very helpful for that. I tried testing the current, and either my multimeter was set up wrong or it's busted or something, but I could not get it to register anything. I had the same setup as I do in the video, except I disconnected one of the legs to the LED, and I put the probes in between the LED and the clip, and I wasn't getting anything at all. So, not really sure what's happening there. Maybe I'll try to use one of the lab multimeters and we'll see what happens. So, gonna keep working on all that stuff, but in the meantime, just a reminder, here's what I'm working with, and then the lower two are the pending parts I'm waiting on. Here's my budget. So for next week, I'm gonna keep working on those pending orders. I'm gonna keep testing and see if I can figure out the amperage, as well as what would happen if I have a couple of tags going. I was able to get 2 from the Amazon order, and if things kind of go south for the Canada parts, maybe I'll just order another set of these, and it can be, I can have like 4 tags or so. And speaking of that, I will need to design an armband for that, so I'll be working on that, and just cleaning up the circuit and making everything a little bit more user-friendly. So here's the instruction video that I was using, and I will include the link to this at the end of the video. Thank you.